Hey, today we're gonna try to have a look at the kHs Formant filter and see what it does and try to replicate its functionality inside of Max for Life. So at first we'll open up the Formant filter just by dragging it in, and here we can see which parameters we have to deal with. So at first we have an X and an Y axis, which are the filter frequency cutoff for both of the Formant filters, the Q or resonance value for these filters, and a low and a high switch. What these exactly do, we can see with a little extra tool. I use the Bertham EQ curve analyzer for that. What this does is just basically sends a little audio impulse through the device, and at the other copy, we can see the curve response with the processed signal of the plugin. So as you can see, by moving around these sliders, we change the cutoff frequency of these peak filters. They are quite high resonant, which we can adjust by this Q value. As we see, the Q value is also connected with the gain factor of these peak filters. So by activating the low and high values, we see that we switch from a peak filter to a low cut or high cut filter. Very interesting also is as we get lower with the frequency, it's always making sure that the lower cutoff is set to the low pass filter and the low cut filter, and the higher cutoff value is always set to the high cut filter. So these are typically basically just biquad filters. And now we're gonna take a look on how to replicate these in Max. At first we start with our plug-in and plug-out objects, just to get our audio in and out of our device. Then we just declare some objects for our parameters. For the X and Y filter frequency cutoff parameters, I just use the live.numbox object. So we just have two of these. For the Q parameter, I use live.dial. And for the low and the high value, I use live.text objects. So at first we have to declare the right values for that. As we can see, the X value goes from 200 Hz to 900 Hz, and it's scaled in a linear way. So we click on the live.numbox value and set it from 200 to 900 with an initial value which is 550. And change that to a frequency parameter with an exponent of 1, so it's linear. Then we have the Y value, which is from 500 to K500. Same procedure, 500, 2500, with an initial parameter of 1500. The Q value has a range from 2 to 16, with an initial value of 4. Also, we should just name it Q 4 to 2 to 16 was right, and the initial value was 4. And we will make sure it's a float value so we can set it to the right parameters. For the text boxes, I will use some pictures. Because in Max we have the lowcut.svg, so we can see the filter curve response more visually. And for the other one, we just use the highcut.svg. Great. I just forgot to set it to a frequency value right here. So great, now we have declared our parameters. So now we want to replicate the functionality in the DSP processing part. So these filters which are used here are typically just biquad filters. In Max we have a separate object for that. And what are biquad filters exactly? If you don't know that, you always can open up the help file and you mostly find a pretty good explanation of what it's capable of and how it's built. So when we have a look here at the coefficients part, we can see here a little diagram. So the digital implementation of a biquad filter is just basically we take the input value and scale it with different parameters, and also have little delay sections of one sample, which is specified by these z-1 value. And these are just added at different points in the signal chain. And with all these connected, we get a filtered audio output here at the Y point. So how we declare what kind of filter type it is by feeding in different filter coefficients. So now, how do we know which filter coefficients we need for our filter response? So that's actually pretty easy, because here's a little object which kind of helps us with that. It's the filter coefficient object. As you can see, we have 5 outputs, and for the biquad we have a signal input and 5 inputs for the coefficients. So we can just hook up the biquad objects. So we actually need 2, because we're working with stereo audio. For the first filter, now we can hook up the signal chains. Oh, that was wrong. To the corresponding in and outlets. And because we have 2 of these filters, we just need another one of that. It's more easy if we copy all together, so we just don't have drag around these much patch cords. So we have now 2 biquad filters in serial. And now we have a look at the filter coefficient part. And we have 3 inlets, one for the frequency value, one for a gain value, and one for the Q value. So it's actually pretty straightforward. We just hook up the Q value to the Q input and the frequency value to the frequency input. As we just saw in the Formant Filter device, the Q value of the peak filters is also connected to the gain parameter of the peak filters. The cool thing is we don't have to care about the gain value if we use the high cut or low cut filters, because we they just don't react in typically to the gain value, so we can just ignore that. A little extra thing we have to declare here is that we need to make sure that the low pass part and the high pass part always use the lowest or highest frequency set through these objects. So we take the minimum object for the first filter and the maximum object for the second one. This makes sure that we always get the minimum value of both of these objects from this output and the maximum value of both of these objects from this output. So we should be already quite close. Now we have to implement the high cut and low cut options. This is actually pretty straightforward. We just need a selector. Oh, I actually have to type it right with 0 and 1 and connect these to our live.text objects. So these are declaring the kind of filters which we use with the filter coefficient objects, and this is actually pretty straightforward. If they are disconnected, we use a peak notch filter. For our first filter, and if it's enabled, we use an high pass filter, which we also will connect here. Now we do the same thing for the other filter. It's a peak notch if it's disabled and a low pass filter if it's enabled. So we connect that to the filter coefficients. So the way how this works, if we click on our live.text object, it will put out a 0 if it's disabled and a 1 if it's enabled. And our selector device will route these objects, zeros to the peak notch message, which is sent to the filter coefficient object, and a low pass message with if the value is 1, which will make it a low pass filter, which is then sent the low pass message to the filter coefficient object. Great. And that's actually kind of what it is. Let's have a look. We now just connect the EQ curve analyzer to our algorithm here and have a look what happens if we now mess around with our different values. As you can see, here are both of our peak and notch filters, which can be varied with the Q value, which is also linked to the gain factor. And we can also use the low cut and the high cut options here. And this is actually all what the kHs Formant filter is doing. So we now actually replicated all of its functionality. A little cool extra thing we could make is that we just add an XY pad to actually control it the same way as it is in the VST version. So we can use the picked slider object for that. You know that maybe from other Ableton devices. And it puts out a value from 0 to 127 for the X and for the Y axis. These we can scale from 0 to 1. Or even better, from 200 to 900 and 500 to 2500. Important is that you set these dots right, because otherwise it's just working with integer values and not with floating point values. Now we prepend a set message, which will make sure that the value of coming out of these objects will only set the message for the number boxes, and the other way around, we multiply the second output of the number boxes, which is always scaled from 0 to 1, and connect this with our XY pad. So now, if we're working with that, the XY pad sets the values for our number boxes, and the number boxes can set the value for our XY pad. Oh, here's a little mistake. Yeah, I just forgot to multiply with 127. Now everything's working correctly. So to build a little cool looking user interface, we just add all our control objects to the presentation mode, which we can open up here and drag them around to the positions we want them to have. You can just declare the position values here in the project inspector, I just want these one to be square, so I put in the value 169, which is actually the height of every Ableton Live device. So it's a good value to remember. Then we drag around our other user interface objects here and give them some little names, like we use a live comment for that. So we knew one is the x-axis and the other one is the y-axis. Just drag them around however you want it. And then we actually add a low and a high cut filter option. Maybe more like this, a little more evenly spaced out. But you can just position the objects however you like. One thing you have to do actually is that you need to go on the View tab and open the Inspector window to make sure you always open your device in presentation mode, and you also declare the width of your device here. So we want kind of width of kind of 300 pixels, I guess, and a height of 169. So just have a look. Ah, that was kind of fitting. You can also just easily drag it around like this to make it fitting for your needs. Now we just do some little color correction, because Ableton is mainly using another color for its XY pads. We can use it by using the dynamic color since Live 11. So we need the LCD text icon or LCD shape. It's kind of the same color for the color and the element color value. So now it's the right color, and if we drag these, it has also the fitting color. And it also will adjust its color depending on the live theme you're using while working. Okay, great. And this is how you can build your own version of the kHs Formant filter in Max for Live. Hope you enjoyed the tutorial and maybe learned something. If you like, leave a comment on the video, or if you have any questions or stuff, just contact me via my social media links in the description below. And if you want to support me for my work, for my Max for Live devices I do and other stuff, you can always make donations via my Gumroad shop, where I sell my Max for Live devices for free. Or I will also do a Patreon in the near future, where you also can donate some money if you like. See you for the next tutorial. Bye bye.